Okay, this is 1% starch. Starch is a really versatile chemical for our lab. We'll use it for enzyme substrate reactions. We'll use it as an indicator in chemistry, or more complicated reactions like iodine clock. Okay, so let's start with our calculations. Our calculations are going to be in percentage, weight by volume. So we're making 1% starch. That is 1 gram in 100 mil. Target volume is 500 mil. So we're going to need 5 grams. So let's get our balance. Not actually going to use a weighing boat. So this is our starch. Make sure that it's starch that's soluble. You can buy starches that are insoluble. Distilled water. So just waiting for that balance. So I've got a thick walled beaker here. Something that can take some heat, because we're going to heat this on the hot plate. Target is 5 grams. As powders go, starch is pretty light. When you're working with it, it's not very dense. Try not to get it up the sides of the walls of the beaker. But not to worry if it does. We're going to do loads of rinses anyway. So this starch is probably going to be used for simple enzyme substrate reactions, for breaking down starches into simple sugars, using enzymes like amylase, and using iodine to tell when it's been broken down. I have used starch before as an indicator for titration involving iodine. It can also be used for making very specific agars for microbiology, or to show a definitive positive test for the presence of starch using iodine in something like food tests. But my favourite use has got to be for the iodine clock. It's one of my favourite reactions to indicate when iodine has been liberated. So a very versatile compound for all sorts of biology and chemistry reactions in school science. Okay, so that's 5 grams, bang on. Start packing up the balance. Put everything else away. Heat a stirrer. Let's get the heater on. No stirring for the minute. We're just going to use the heater. Now this bit's important. We're going to add a little bit of distilled water. Loosen that starch up. Get it hydrated. And we're looking for a paste. And it can be quite a loose paste. You don't want it too thick. Very much like if you were making a cornstarch slurry for something like Chinese cooking to thicken sauces. I am going to need a stir bar. I'm not going to need it right now this second. I'll just get one ready. So that starch is insoluble in water at room temperature. It's not going to dissolve until we add heat. But it is really important that we do not walk away from the solution when we're making it. If you walk away from a starch solution, it is guaranteed to burn. It will decompose from starch into its sugars. The minimal amount of water in the bottom of the beaker, that will evaporate. You basically get caramel and then carbon. So what you've got are these big branch structures of polysaccharides, so repeating sugar units. So repeating sugars that eventually branch out into other repeating sugars, which makes these big structures, which are called a starch granule. And in this process, we're just trying to drive water into those structures, break it up a little bit so that it becomes soluble and clear. And this process is called gelatinization. So over the next few minutes, you'll see your solution get thicker, clearer. And I'm just going to be adding a little bit of water here and there, just to make sure the solution doesn't burn, lose water through evaporation. I want to make sure that I get all of the walls of the beaker completely clear of any starch. And this process does take a few minutes, so it's really easy to get distracted by another job, or you're making other solutions at the same time. But honestly, you're better off not walking away from it and having to repeat this whole process again. So every now and again, I'm just going to give the solution a little bit of a stir, making sure I handle it by the rim of the beaker, because that's the coolest part. The gelatinization process is going to happen around 70 to 80 degrees. You want to try and keep it at that temp. Keep adding water until it's gone clear. So that's nearly there now. I'm really making sure that I get all the sides of the beaker clean. That viscous texture that it has does make it a little bit annoying if you're making stronger concentrations of starch. But something like 1% is really versatile and very manageable to make. And now I'm going to add my stir bar. I'm going to make sure everything's nice and homogeneous and nice and well mixed. And I'm going to start adding more water. Try to get the walls of the beaker, turning the stirring up. And I'm looking for about 1/3 of my final volume. Around 150ml mark, 200ml mark. Just because I want lots of room for rinses. Okay, now let's make sure the whole thing gets nice and hot. Just make sure we've got every granule dissolved. You could cover this with a watch glass at this point. Probably worth mentioning that some protocols might call for a starch suspension, which is the same process without any heat. But that solution will settle out over time. You usually have to shake it before use. You're aiming for those starch granules just to be really finely dispersed in the water. It'll still be really, really cloudy. But if you're doing something like brownie emulsion or making oobleck, so that's been going for a few minutes now. I'm going to get a heatproof mat, transfer that to a heatproof mat, start letting that cool. Get my retriever. Politely remind everyone in the lab that the hot plate's still hot. And again, lots of rinses because of that gel that we've made. I've heard of people making starch solutions with freshly boiled water instead of using a heater stirrer. Use some kettle water. Can't really be sure of contaminants, but this way's a little cleaner. And this is the way I was taught. Final rinses now. And I'm going to start adding some water to the volumetric flask. So maybe just 1/3 of the final volume. So I've got 1/3 of the final volume in the volumetric flask. And then I've got another 1/3 of the final volume in the beaker. That'll give me another about 150ml to play with for rinses and for cooling. So just decant that in. Have seen people make starch solutions in the volumetric itself as well. With the beaker you've got a little bit more control over the heat and over your rinses. So I've left loads of room in that volumetric flask for rinses. I'm using a distilled water bottle with a really, really fine tip. So I can really get in and make sure everything's nice and cleared out. Right around the rim, give it a swirl. Pour. Same again. Minimum 3 rinses. With starch you're going to do loads though, because it's so thick. I still don't want to top up to my final volume just yet. I'm going to wait. Have a little clear down. Because actually what I really want is for that whole solution to cool. You could top up to the final volume now, but either way, this meniscus is going to drop. I'm very generous with my rinses, but just to illustrate the point, I want to make sure I get every single bit of starch out of there. Okay, so I'm happy with that. I'm just going to top up just to the neck, but not to the volumetric graduation just yet. Now I've got to let that cool to room temp. In a pinch, you can definitely use an ice bath to cool it quicker. At this stage, all of the starch granules are nice and hydrated. So I'm going to get my bun, but I'm not going to fit it properly. I'm going to balance it on the side to let the air get in. Hot things cool down to room temp, cold things heat up to room temp. What you don't want to do is fit that bun, have it cool down, it create a vacuum, and then your bun gets stuck in the neck of the volumetric flask. And now we've literally just got to wait for it to cool down so we can clear up a little bit. But where we've added so much water to the hot solution, it should be fine. Maybe half an hour, but if you want to be sure, leave it longer or use a thermometer. Okay, so I'm happy that's cooled to room temp now. So I'm just going to do my final top up to the line, making sure my meniscus is at eye level. Doing it nice and slowly. Okay, happy with that. Fit the bung on. And as always, all unmarked solutions contain a fast-acting poison that will kill you instantly. So, we're going to make sure we label it. 1% starch. And we've got one more little job to do. We just got to quickly do our inverts. So we'll just do 10 inverts. Make sure that's really nice and homogeneous, really well mixed and evenly distributed. Ideally, we want to store it in the fridge. You can decant into Durans, or you can store it in the volumetric flask. But just be aware, 1% starch will always grow funguses, molds, bacteria, because you're basically giving just a medium for those sorts of things to grow in, and those spores will come in from the air. If you want to be sure, you can autoclave it or make it fresh every single time. And that's 1% starch done.